Hello everyone and welcome to the third session on moving load. I am Surajit Ghosh and in this session I will discuss how to place a moving load assembly on any part of the structure using correct reference point and generate multiple loads at fixed interval with moving load generator. Also, there was a mistake related to wheel load sequence that I have mentioned in my last video. I will discuss this in detail. In last session, I have covered how to create a vehicle definition with proper wheel load and axle distance. This is the first step to apply a moving load in STAAD, and depending on the vehicle information, load is applied on the structure. We can define any type of vehicle like a car or truck and crane load in vehicle definition by providing wheel load, distance between wheels and width of vehicle, or by importing all this information from an external text file. For more details, check my previous session. Once the vehicle definition or wheel loads are specified, we can apply this load on any part of the structure and generate required load case. This is the most important step, as with improper input, generated loads will be erroneous or applied beyond the structure. First, I will discuss how program read the vehicle definition and apply wheel load on the structure. For this, I will use this simple frame model with long and cross-directional beam and pier, like any bridge. Width is 3.6 meter and length is 24 meter. A 3-axle truck similar to HS20 vehicle defined under ASTO code will be used for moving load application. Front wheel load of this vehicle for one side is 50 kN and each rear wheel load is 90 kN. Center to center distance of wheel is 3 meter and 5 meter from the front and width is 1.8 meter. In last video, I have discussed how to add this type of vehicle load, and there was one mistake. Under vehicle definition, we need to specify wheel load of last axle as the first load. This is not the load of front wheel. If we want to add this truck load in STAAD, we should start from the rear wheel and specify the first load value as 90 kN, followed by another 90 kN load. Distance is 5 meter. Then we should provide the front wheel load, which is 50 kN, and distance as 3 meter. This is the correct order of wheel load, and I have incorrectly reversed the order in last video. Sorry for that, I didn't notice it earlier. With previous input, load will be applied correctly, but movement of the vehicle will be reversed. I will discuss this later in detail. To summarize, for vehicle definition, wheel load of each side is required. If combined load of an axle is available, we need to divide it with wheel number or 2. Then we can add this load starting from the rear axle in the direction of movement and corresponding wheel distance. With this input, vehicle definition is now complete and we can apply the load on the structure. For that, we can use vehicle load generator option available in the ribbon, which will open a load generation window. Also, we can access this from Add Load Case option. In this window, we need to specify the number of load case required to cover the entire span or desired range of moving load. This number should be calculated using traveling distance and load increment value. For that, first we need to understand how the load is applied on the structure. For now, I will generate 20 loads. If required, I'll revisit this page and change the generated load case number. Also, we can select any predefined load case from the drop-down and combine it with this moving load. For now, I'll skip this additional load. This will be covered later during load combination. With this input, 20 loads are generated starting from load case 1. Moving load is nothing but a group of separated load case, and under each load case, a vertical load component is added at a particular location of the structure. To generate this load item, we need to specify few information, including type of vehicle, initial position of load, and load increment value. These inputs are very important and entire moving load assignment depends on this. For structural analysis, what is the initial position of this truck? When the front wheel enters the bridge deck, right? Let's assume it is moving from left to right. Under first moving load case, front wheel load is applied on the left beam. Then this truck or wheel load will move to the right and gradually other wheel loads are applied on the structure at fixed interval. This is the concept of moving load. We can inform STAAD about this load assignment using initial load position and increment value. I will start with initial load position input, which is the absolute node coordinate of reference point, and it is not the location of front wheel. Rather, STAAD considers the rearmost right wheel as the reference point of load. This logic is hard-coded, and we need to specify exact coordinate of this node as x, y, and z value. Coordinate of this beam is 0, 5, and 0, which we can check from the node tooltip. Y coordinate will remain same, 5 meter, but x and z coordinate are not same. We need to calculate this using length and width of this vehicle. Length is 8 meter and width is 1.8 meter. If the front left wheel is placed at this corner node, then its coordinate is 0, 0, and coordinate of this reference point is -8, 1.8. X is in negative direction and Z in positive direction. It is not very complicated. First, we need to fix the front wheel location, get the coordinate, then we can calculate the coordinate of reference point using simple geometry and vehicle dimension. For this vehicle, X is -8 and Z is 1.8. We need to be very careful. If there is any mistake, generated loads will be incorrect. Next, we need to specify the load increment value which fix the load position of all subsequent load case. This is the first position of moving load, and under next load case, this load will be applied somewhere else. That distance is specified using increment value. 1 meter increment means under next load case, same load is applied after 1 meter from the current position. In simple word, load will be moved by 1 meter in the specified direction. For this model, direction of movement is parallel to positive global x, so we can specify only x increment value. If both x and z increments are specified, then load will be moved in the resultant direction, like when a bridge is skewed to the global axis. I'll use the load increment value as 1 meter. Generated load case number depends on this, and for small increment, more loads will be added within a closed range. This will not only increase the analysis time, we also need to spend more time to sort the results and find out the critical location. If the loads are very close, change in analysis result is negligible. So unless it is required, it is not recommended to specify a small increment value. Normally 1 or 2 wheel diameter is considered as increment value. This range input is optional. We can restrict the load movement within a range. I'll use the default option. By the way, this type is the identification number of vehicle definition. If there are multiple vehicle definition, we can select it from the drop-down. I'll show you how we can combine multiple vehicle loads from different directions using this input. With this, our load assignment is complete. Now the question is whether this moving load is applied correctly or not. These loads are not visible in the UI. If we click on loading diagram, it throws an error. This is a generated load, like seismic load, and for generated loads, program internally calculates the load intensity and location during analysis. Before analysis, none of the moving load item is generated or even exist in the model, and these are only few blank load case without any load. That's why no load display is available, and we need to analyze the model first to check load application point on the structure. After analysis, we can check individual load item from load window. Under first load case, front wheel load is applied at the left end of this deck. Rest of the wheels are outside the bridge. Then this load starts to move in x direction by 1 meter, and rest of the wheel loads are gradually applied on the structure. Finally, all 3 axle loads are applied on the deck, but this load assembly does not travel till the end. We have generated only 20 loads, which is not sufficient to cover the entire span of this bridge, and that's why it stops in the middle. To fix this problem, we need to increase the generated load case number. How many loads are required to apply load on entire span? That we need to calculate first from traveling distance. Load assignment starts when the front wheel touches the left beam of this bridge and ends when the rear wheel exits the right beam. After that, no load is applied on the structure. Hence, this is the end point of moving load. We can calculate the traveling distance of the front or rear wheel. Front wheel of this truck moves the entire length of the bridge plus truck length, which is 24 meter plus 8 meter or 32 meter. If we divide this length with load increment value, that gives us the internal division number, and for load application point, we need to add one additional point. For this load, increment length is 1 meter, so we need 33 loads to cover this distance. To calculate the required load number, first calculate the total traveling distance by adding the vehicle length with structure length, then divide it with the load increment value and add 1. We can revisit the load input page and change the number from 20 to 33 and reanalyze. There are few warnings related to moving load. Whether we can ignore this or need to rectify the load input, that I'll cover in the next part. Once again, check the load items. 33 loads are generated starting from left end of the structure, and now this moving load is applied on entire span of the structure. So our calculation and inputs are correct. Note that if the vehicle does not cover the entire length and travels within a safe distance, then this load calculation logic is not applicable. For example, normally any EOT crane does not travel till the end of gantry girder. There is a safe edge distance, and to apply the crane load correctly, we need to calculate the traveling distance of crane. Can we apply this load from right to left or combine multiple vehicle movements, which is a realistic condition for any bridge with two-way traffic? That I will cover in the next video. Keep watching.